Hello, everybody, and welcome to Wednesday, February 24th, 2021. Mr. Parrott here with your rundown of what we're doing today. We're going to get weird, but weird for day number 2. Wait, that's 4. Number 2. There we go. Bell ringer. Make sure that you answer your bell ringer first and foremost there. Get those answered up. And we're going to look at our second half of weird genetics. So without further ado, we'll pop open word genetics. Our 2 word genetics. Oh, I got the hiccups right now. Scaring you. Going on there. Maybe that scared the hiccups out of me. Who knows? We'll see if I still record this video. First weird genetics that we're going to talk about is what is called multiple alleles. And the weird thing about this one is that you are going to be using multiple letters for one trait, because it is not something that just involves dominant and recessive, so we can't just use uppercase and lowercase, but we have to bring in another letter to symbolize things. And the most common example for this is our blood types, because we have an A allele, a B allele, and an O allele, and that's how we get our different combinations of blood. You have your O blood, you have your A blood, your B blood, and your AB blood. So it actually is a multiple allele thing that gives you your blood type. You can kind of see over here with our phenos what we have, and then the possible different combinations of letters going on. And we'll explain that when we start looking at some of the problems here later on. But that is multiple alleles. So let's look at a problem, because the easiest way to look through this is looking at a problem. So I am going to take a snapshot of this. If you want to try it on your own here, make sure that you pause the video first, but I'm going to show you how to do these. Let me bring this over here. So I kind of got it chopped off here at the top. Let me move myself over here so we can kind of see everything. There we go. So what we have here is we got a type A parent matching with a type O parent. And if you look over here, there's 2 ways to write type A's. That's why we have 2 different combinations here. So I'm going to go ahead and put, let's say dad is the type A, so I'm going to put him on top. You could either write a type A as an AA or an AO. Because we don't exactly know what dad is, that's what we'll have to go with. I didn't leave myself any space on the side here. Mom, on the other hand, let's say she's the type O. There's only one way to make a type O. So we're going to put these on the side, all the O's. And then all we got to do is just do what our normal Punnett square is. And we go AO, AO. This one's actually all AOs. Whereas the second combination, we get some AOs when Papa drops the A in there, but then we'd get a chance of having just type O in the long run. So with these, you can't really, we could do percentages of it, but usually I will ask you specifically, what are the chances of having a type A kid versus a type O kid. Usually it's still going to be within 1 square if I do ask you things. So it would be in combo number 2 that you created, what is the percent chance of having an O kid? Or in combo number 1, what is your percent chance of getting a type A kid? But the key thing with this is that you have to know that there are different combinations that'll give you different blood types there. So you really have to focus on the genotypes and then what those end up making out of the phenos. And you're going to do some problems like this in the assignment tonight where you'll have to show both ways in which it will exist. The final one that we're going to take a look at, let me put myself back into the corner here, is our sex chromosome. So the things that are male and the things that are female. These are going to be our sex chromosomes that determine things like male and female, as well as other characteristics that are more male or female-esque, which is based off of your genetics. Going on there as far as what chromosomes that you end up having. The traits that are passed specifically on these sex chromosomes are what are called sex-linked genes. And there's a couple of them that we'll end up looking at, but a couple of things that exist on just we call them the X and the Y chromosomes. You may remember that from our dragon activity from last week, or earlier this week actually, where we dealt with X's and Y's to determine whether you are male or female for things. But for specifically the sex-linked genes, they are on one of those chromosomes, specifically the X chromosome there. And some traits that are like that are color blindness, hemophilia, which is where if you bleed or if you get cut, you just keep on bleeding and it takes a longer time for your blood to clot up. And then there's also baldness, is a sex-linked gene, which is why it's usually called male pattern baldness. But going bald is in your genetic traits as well, from when your hair just stops growing. So how do these traits work? We have to know that there are X's and Y's. Males are XY, females are XX. Specifically, the sex-linked genes occur on the X chromosome, so the Y's get kind of left out. The Y only signifies whether you are male or female. Females are going to work like normal Punnett squares because they can be dominant, recessive, or recessive, or capital, lowercase for their alleles. So females, you have to have two recessives in order to be a recessive yourself. Males, on the other hand, because they only have one X, this is the weird thing, because they only have one X, it is a 50-50 chance that they could be dominant or recessive depending on what they could inherit from their parents. So, because they can only receive either one dominant allele or they either receive one recessive allele, which for a lot of these characteristics that we talk about today involving sex-linked traits, these are always going to be a little bit more common in males than they are in females because males have a higher probability to become either dominant or recessive. It is not an equal 2/3 to 1/3 chance. It is a 50-50 chance of getting the dominant versus recessive going on there. So how does this all work? You can watch our video here, but let's look at the actual problem itself. Let me bring up a new one of these little snipperdoodles. I'll capture this. Remember, if you want to pause the video. But I'm going to show you our different combinations that are going to be possible here. Now, there's two things that happen with this, and this is where it gets really weird because we have both the trait and we have to keep track of what is male and what is female. So, you'll notice that there's X's and Y's in here. My suggestion is always fill out the X part first, the X's and the Y's. So do your normal Punnett square doing your X's and your Y's. So here's an X with a Y. Two X's are going to be over here. Here's an X with a Y, and we got two X's going over here. That would always be my first step in doing this. Then if you look closely, the X's have traits of their own on them. So what you need to do now is go back and do the actual trait and attach the letters to back up to the X's. So in this case, with our first one here, we have X big B Y. So since the X and the big B is coming over here from mom, that's going to be there. X big B is going to carry over into this one from mom. Dad's X has a little b on it. So boop, one of those X's will have a little b. You get a big one from over here and a little one from up top. Down below, mom has a little b there. So that is going to be an X little b Y kid. And then this one's going to have two little b's in this case. Boop, going on there. So it's a little bit more complicated, and this is where it gets a little bit trickier, but my suggestion is to chop this into two sections. Do all the X part first, and the Y's, and then go back and deal with the trait. Because it works like a Punnett square, you're just doing the Punnett square twice. Once for the X and the Y's, and then once for the B's. And this is actually how you do the more complicated problems involving multiple traits. Because really, we just did multiple traits there. We did the X's and we also did the B's at the same time. But here you would have a male and a female, one of them, or the two, out of the two males that are there, I guess I can use my pen. This one would be dominant, the one up top that my pencil's hovering over. The one on the bottom would be recessive. Out of the ones over here for the females, the XX up top, since it has a capital letter, it's dominant. Since both of these have little letters, it would be recessive. So it works just like a normal Punnett square. If we were to take away the X and the Y's, all that we would be left with are B's. The other weird thing is that Y doesn't get anything added to it. Y is the loner of the group here. Y gets nothing except just the Y. So there's no B's that attach themselves to the Y. It is only the X's. So for the males, you're only going to have 3 letters. For the females, you're going to have 4 letters to deal with. And that's an example of our sex-linked traits and our characteristics. Let's look at your assignment now, because you're going to do these as a part of day 2. This is the same assignment as yesterday, except you are continuing now on day 2 stations. You first start off with multiple alleles. Here is the chart for what your different genotypes and phenotypes are. I give you what father and mother are, and you need to solve the Punnett square. Ultimately, what is going to happen as you jump from slide to slide, you are going to get a different combination of parents. So this is parent set number 1, and you're going to see what their potential babies are. Here's parent set number 2, and you're going to see what the parents are going to be. Now in this case, there is 2 different combos because you have a type B parent. So that's BB or BO as that parent. You'd have parent set number 3, and then parent set number 4, where there can be multiple combos. Whenever there's 2 Punnett squares, that means that there's 2 different ways to do it. So make sure that you do 2 things for that. And then at the end, what we're going to be doing is that there's going to be a baby that is born from those 4 parents. Each one of them has their own baby. Each one of those babies has a unique blood type. You need to figure out what baby should belong to each set of parents. So it's like a little mystery type activity of whose baby is who. There was a mix-up at the hospital. The only way we can figure out what baby is what is by blood typing them. And they would match up back with the parents. So you'll need to figure out how to go through and match up the different blood types there. For the sex-linked, you need to write out the genotype for male and female. And then you can just copy and paste these options to fill in the different sections here. Because they use the little capital letters in there, just copy and paste those things into it. It's real easy to do because it's just in the box itself, so you can just copy that and paste it. That way you keep everything the same. But this is kind of like a little multiple choice thing or matching where you have to match up what the different things would be going on there for both males and females. And then there is 2 problems to do regarding the sex-linked characteristics. And once again, you can copy and paste those things from slide number, 19? Should be 19 here. I'm going to change that real quick. It must have been 17 at one point, but we added a couple more. So to slide number 19 to help create the Punnett squares. Each one of the, remember, do your dragging and the dropping down for things as they go through. If you have any questions about things, do not hesitate to ask. Otherwise, I'll hopefully see you soon, or sooner rather than later, and you're back with us in class. Because this stuff is a lot easier to understand, probably, if you're here working through the problems with us, instead of just getting the video version of it. But if you have any problems, do not hesitate to ask. I know it's a little bit longer one because these ones get a little bit weird, but hopefully you stuck it out to the end. If you have any questions, just email me up. If you want to Google Meet and talk about it that way, we can also work something out. Just let me know through email. But otherwise, I'll hopefully see you later. Everything involving this is going to be due up, so make sure that's all due up, or if you have any questions, that you ask me some questions about it. But now that I'm ending on the final screen here, I will see you later. Bye.